Alright, so today's lesson is I can graph linear inequalities in two variables. And this is a lot of similarities to graphing regular lines, except for a lot more solutions to a linear inequality than there is to just a regular linear equation. Alright, so if I'm presented with a problem like this, and it says graph x minus y is greater than 2. Okay, this is going to go back to what we learned a little bit from last week, in that to graph this, the first thing I have to do is put it in slope-intercept form. So I have to get the y by itself. Okay, so I get x minus y is greater than 2. And this is going to borrow some rules from when I solved equalities, inequalities in one variable with just an x. And also from when I solved regular equalities for y. So we're going to get this in slope-intercept form. So remember, I'm looking for something that looks similar to y equals mx plus b, except for this symbol is no longer there, right? We're going to use one of the inequality symbols. So to get y by itself, got to get rid of this x. So I'm going to subtract x from both sides. Remember, I can't subtract x and 2 because they don't have the same variable. So it's just going to be negative y greater than negative x plus 2. And also remember, the negative from up here will transfer down here. Alright, now I got to get y by itself, so it's still got to get rid of that negative. So I'm going to divide everything by negative 1. It's going to make that positive. So, this is where I say it borrows from single variable inequalities, because I'm dividing everything by a negative. And remember, when we divide everything by a negative, what happens? Think about it for a second. Do I keep the same symbol or do I change it? To keep it, change it, keep it, change it. Oh, remember, I have to flip it, right? I'm going to divide by a negative, so I have to flip the sign to match. So it's negative x over negative 1 is positive x. Positive 2 over negative 1 is negative 2. Remember, there is a 1 in front of this x. Okay, so second, now I've got this y equals mx plus b form, except for, it's y is less than 1x minus 2. Okay, and then I need to graph the line. Okay, and so I want to get my slope and my y-intercept. So remember, slope is m, y-intercept is b. Okay, so remember, slope up here with the x is 1, and I'll just turn that into a fraction to help me out. Remember, 1 over 1, rise over run. And my y-intercept in b is negative 2. Okay, remember, compare it to slope-intercept form. I've got y-intercept negative 2. Let's go over here to the graph. Starting at the origin, I'm going to graph my y-intercept of negative 2. Okay, start there first. Okay, and my slope is 1 over 1, so it's up 1 over 1. Up 1 over 1. And graph as many as you need to get a straight enough looking line. Alright, now here's where the next part of this graph gets a little bit special, because I can't just draw in a solid line. Remember from last week, if I've got a symbol like this, I have to check to see if that line is included in my solution or not. And since this is just a less than symbol, what kind of line do we use or what kind of line do I draw in? Because I can't, it's not equal to, right? It's just less than this line, so it's more like a boundary. So think about that. What line should I draw? Should it be solid or should it be dashed or dotted? Right, and you should be thinking that it should be dashed, right, or dotted, either one, right? As long as it doesn't look like a full-on line, we're fine, because we're going to assume that, well, we know, not just assume, that this line is not included in that solution. All right, and then we're going to pick a test point. And I always pick, if it's not included, I always pick 0, 0, because that's the easiest point to plug into my equation and do something with. Okay, so I'm going to plug in 0 for both x and y and check. Right, so I get 0 for y is less than 0 for x minus 2. And I get 0 is less than negative 2. Okay, so last thing we do, the third step, is plug in 0, 0 and check, because I know that this line isn't my only solution. Remember when we did number lines and we had to check, and we drew on the thing, we put the point, and we checked to see which direction the arrow went? Same thing here, except for I'm looking at this graph. I want to see which direction are my solutions in. So I plug in 0, 0, and I want to check to see if it's true. Okay, so 0 is less than -2. That's not true, right? 0 is greater than -2 on a number line. So that means, what do you think? If I want to shade in solutions, am I going to shade towards 0 or away from 0? Well, since it's not true when I plug in 0, I'm going to shade away from 0. So my solutions to this problem are everything underneath this dotted line, right? If I plug in anything underneath here, then those are my solutions. And remember, nothing on this line is included because it's dotted, right? It needs to be a solid line for it to be included. All right, so second example. Okay, I want you guys to try this real quick on your own, and then we'll go over it. So pause the video, try to do this one on your own, see what you get. Alright, so what you should have done, solve for x, or solve for y first. So I'm going to subtract 2x from both sides. Get 4y is greater than or equal to -2x plus 4. Then, to get the y by itself, divide everything by +4. And remember, I don't have to do anything to the sign because I'm dividing by positive instead of a negative. So your y is greater than or equal to -2 over 4. Well, that reduces. I can divide both of those by 2. So I'm going to change that to -1/2 x. And then 4 over 4 is +1. Alright, so my slope is -1/2. My y-intercept is 1. So I'm going to go ahead and graph that. So start with the y-intercept. Remember, alphabetical order. Start with your b. b is +1, so I'm going to go up 1, mark my point. My slope, rise over run, -1 over 2, which means you should have gone down 1 to the right 2, down 1 to the right 2, and as far as I can go with that. Alright, now looking at this symbol, it's a greater than or equal to, so when I decide what line I need to draw in, it needs to be a solid line, right? Because all of those are included in my solution. Okay, so you should have had a solid line for that because of the bar underneath means equal to, which means that this is in fact included. Okay, so now we've got the line in. Let's put in our test point. 0, 0 is not on my line, so I'm going to use it. 0 greater than or equal to, well, 0, plug in 0 for x, so 0 plus 1. Okay, if I simplify that, I get 0 is greater than or equal to 1. Is that true? Well, no. So I want to shade everything away from 0, so I'm going to go above this line, right? Everything on top of it. We don't want 0 included, so it's everything in here are my solutions. Okay. So remember, we're checking this point to see if it works. If it's not a solution, then I know that my shaded area is not going to include that, so I want to include everything that's not in that space. Alright, so this is what you should have gotten. Make sure you change your answer if you made a small mistake. Alright. Last one. So determine if these points are a solution to the following inequality. So looking at this, remember the shaded areas are my solutions. And think to yourself for a second, this is a dotted line. Is it included? And the answer is no. Okay, this is a dotted line, we don't include it. I want to check all 4 of these points. So I have -4, -5. It's down, I'm going to graph that, it's right here. Here's A. Got 0, -5. It's right here. That's my B. -3, -2. It's right here. That's C. And 0, +1. That's my D. Alright, so we're going to check to see if these are solutions. Well, A is completely outside of my shaded area. We know that the shaded part are my solutions, so is A a solution? The answer, no, right? It's out here, not a solution. B, well, B exists on the dotted line. It is touching the shaded area. However, we know that because it's on the dotted line, that is not a solution. So that one is also no. And C, same reasoning, right? It's on the dotted line. Despite touching the shaded area, it's not actually a part of the solution. The answer to that is also no. And D, safely inside, way inside the shaded area. So 0, 1 is a possible solution to this inequality, D being the only answer. All right, so try the practice if you'd like, but be ready to talk about this tomorrow in class.